One of the goals of today's lecture will be to address the age-old question, zip files. How do they work? You may have at some point made a zip file or downloaded one from the internet, and the basic idea is that given a text file like, say, mobydick.txt, which is 643,207 bytes, if I were to zip this file, I produce a mobydick.zip file, which is smaller. Then later, I can unzip that file, and if I create a new file called unzipped.txt, and I ask for the difference between the original and the one we've just unzipped, we see there is no difference. So how does that work? That's going to be one of the questions we try and address today. Now the reason we're doing this is because it's actually going to bring together a number of different topics from the course, data structures, algorithms, and it will also lead into a closing discussion of complexity theory. So in order to address this problem, I'm going to set up a model for how compression works. Given a sequence of bits, okay, so all data on a computer is given as a sequence of bits, that is, you can think of them as zeros and ones, we're going to feed them to a compression algorithm, and that's going to produce a sequence of compressed bits, 1, 0, 0, 1, 0, 1, and so forth. We don't really care about this exact bit sequence. But the key point is that given that bit sequence, we can feed it to a corresponding decompression algorithm and get back the exact bit sequence we had before. This is going to be a lossless model of compression, and it is going to enforce the rule that no information is lost. So we don't lose anything. We get every single bit back. And interestingly, we find that even with lossless compression, where we don't lose any information at all, the text files like, say, mobydick.txt, they were often compressible by 70% or more. That's pretty cool, and we're going to try and understand why that works. So in the next video, we're going to kick this off and talk about one very basic technique for this, known as a prefix-free code.